Hello everyone and welcome. I am Gokula Vashni, Assistant Professor in the Department of Food Technology. So today we are going to explore a fascinating and essential part of modern food engineering, that is food sensors and their types. So let us jump into the topic. In today's smart food system, food production to packaging sensors play a critical role in ensuring food safety, quality, efficiency and traceability. So let us explore how sensors help transform the food industry from farm to fork. So, did you know the global food sensor market is projected to reach 24.7 billion by 2007? That's because food sensors are now key to driving the smart data-driven decision making. So, they help industries to ensure the food safety, reducing foodborne illness, maintain quality control, minimizing the product recalls, reduce food waste by monitoring the freshness and spoilage, and improve process optimization like reducing energy and water storage. So sensors are not just a tech tool, and they are the strategic tool for sustaining and safe food system. So next, let us see about the chemical sensors which detect molecular change in foods. So these sensors usually consist of a selective layer that interacts with the specific chemical or gases in the food and then produce a measurable signal. So for example, gas sensor detect gas like ethylene to monitor the ripening in fruits, and pH sensor is useful in fermentation, sauce formulation or meat freshness detection. And colorimetric sensors, these sensors detect the color change in the presence of certain compounds like histamine in spoiled fish. So they are the compact, fast and ideal for real-time freshness monitoring. So on coming to the application, chemical sensors are used widely in food processing. So spoilage detection is detected by the ammonia sensors, which helps to detect the protein breakdown in meat or fish. And fruit freshness detects the ethylene gas. Sensors are used in packaging to track the ripening stages of the fruits. Adulteration detection uses the NIR spectroscopy to detect the water in milk or almond oil and mustard oil. And ingredients analysis like electronic nose or eNose can identify the aroma profile in high-end product like wine, coffee and spices. So these applications are helping the companies make fast and informed decisions in the quality control. So next, let us see about the biosensors, which combine the biology with electronic. So biosensors work by using a biological recognition element like enzyme, antibodies or DNA, which react with a specific substance and produce a signal. So the types of biosensors include enzymatic, immunosensors and DNA biosensors. Enzymatic used to detect the sugars like glucose in juices, and immunosensors detect all allergens or pathogens using antibodies. And DNA sensors uses rapid identification of genetic makers. For example, in GMOs, they are highly specific and ideal for trace level detections. So where are these biosensors used in food systems? So let us see about it. So for pathogen detection, they can rapidly detect E. coli or salmonella in raw poultry and meat. And in allergic screening, they detect the trace level of peanuts, gluten or dairy in allergen-free foods. And in toxin detection such as mycotoxin in grains or marine toxin in seafoods. And antibiotic residues in milk or meat, ensuring safe level before reaching consumers. So their speed and sensitivity makes them a powerful frontline tool in food industry systems. So next, let us see about the physical sensors which measure the mechanical and environmental properties. So these include temperature sensors, moisture sensor, pressure sensor, viscosity texture sensors. So in the temperature sensor, thermostats help to control the heat during cooking and freezing. And in moisture sensor, capacitive sensors help monitor grain drying or dough mixing. And in the pressure sensor, monitor fluid flows in a pipeline or detect the steel integrity in packages. And viscosity texture sensor, it is used in food rheology labs to test sauces, batters and spreads. So they are helpful in maintaining the physical consistency in products, which is crucial for the consumer satisfaction. Next, the applications of physical sensors include cold chain monitoring, baking and extrusion, beverage production, texture testing and packaging integrity. So the wireless temperature loggers ensures the safe refrigeration during the transport, and moisture sensor helps to maintain the consistency of the dough, while the flow meter ensures the precision mixing of the juices or syrup. And in the texture testing, rehometers access snack crispiness or fruit firmness, and in the packaging integrity, pressure sensors are find leaks in vacuum or modified atmosphere packaging. So these sensors allow real-time adjustment to prevent loss and ensure product consistency. And at the last, while ensuring the sensors are powerful, they are not without challenges. So cost and selectivity, interference and data integration are much to be noted. So some sensors still struggle with accuracy in mixed environment, while other substance in food can affect the readings, and also the real-time sensors detect the data needs proper software and networks. So now the good news is the technology is advancing quickly, and the miniaturization of the sensor is done, and IoT is combined with AI, and non-invasive methods like histospectral image and emerging in the inspections, and a sustainability focused sensor helps to cut the waste and save the resources. The future of food sensors, to sum up, sensors are shaping the smarter, safer and more sustainable food system. They support the better traceability, faster decision making, lower the waste products and make the product very safer. So as a food technologist, investing in and understanding the sensor technology will be the key to solving global food challenging and driving the industry transformation. So let us embrace this further and make our food system not just a better but a brilliant. So thank you. We shall see in our next presentation.